Hey guys, we're going to start today with lesson 4 for module 2. You'll notice we skipped one for lesson 3, but that's because I combined both of them together with lesson 2. So module 2, lesson 2 actually includes lesson 2 and 3. So now we're going to go straight to lesson 4, which is the reflections. So we learned in lesson 2 and 3 what translations do, that they're a slide, that they preserve that length and measure, nothing changes except for the location. Now we're going to look at a reflection. So what you need to know today is what a reflection is and how to define that reflection and perform that reflection. Using your transparency, you need to be able to show that reflections share those same properties as a translation. So if it starts as a line, it ends as a line. It starts as an angle, ends as an angle. Nothing changes shape or size. It starts with parallel lines. Even after you reflect them, you still have parallel lines. And this last one, all it's saying is that when you have reflection from a line of reflection, that line of reflection is going to be exactly halfway across from the original to the reflected image. So here's our first example. It's a reflection that's already been done for you. If you were to reflect this, if this is my line L, this is my line of reflection. So with translations, you need a vector. With reflections, you need a line of reflection. So this is going to be called the line of reflection, if you want to take a note of that, line of reflection. Because if you're going to reflect something, you have to have something to reflect it across. So this is the line of reflection. Then this figure S, notice that we know that this is the original. We talked about it last time. This is the original, and this is the new, or this is the pre-image, and this is the image. I know that because of this prime notation. That prime notation says I know that that means it is the new one. Okay? So they took each of these points. You would, on your transparency, you would trace this line L, you would trace these key points here, you know how many's in each one of them. You take your transparency and you flip it so that your line L matches right back up to where it started with. So after you flip your paper, this line L that you drew needs to be in that same spot. And when it is, you'll notice that the lines, these points that you plotted, are going to be the exact same distance away from line L as they were over here. And we would call this S prime. Same thing would happen down here with this T prime. Now notice, this is T prime. That means which figure did they start with? Not this one. They started with T, the original T. Okay, so you're going to plot the points. Let's just do the key points. And you always go ahead and draw that line of reflection. You pick up your transparency, you lay it back so that this line of reflection matches the exact same, and what you'll notice is each of the points that you outlined over there are going to be perfect over here. And we're going to call this T prime because it is our new one. Okay, so that is a reflection, and that's how you perform a reflection. What you have to have is your line of reflection. What you're going to notice is that the size and the shape stays exactly the same after it's been reflected because it is a rigid motion. All right. The second example here. With the second example, it shows the same thing, but this time we have a horizontal line of reflection, and that's okay too. We can have any line of reflection. Your line of reflection can be vertical, it can be horizontal, it can be diagonal. You could have a diagonal line of reflection and reflect the figure across it just the same way. You pick it up, you throw it over, and you're going to get the exact same figure. So in this one, you would trace that black figure that it started out with, you would trace your line of reflection, you trace that point P, you pick up your transparency, you flip it over, you make sure that your line of reflection is there, you make sure that your point P stays the same, and what you'll notice is down here would be your new figure, which they call T prime. They have this prime notation because it is the new figure. But what you'll notice about point P is that it never moved. Point P and point P prime are in the exact same location because they are on the line of reflection. When I flip it over and I line it back up, it doesn't change. It's still right where it is, but you still have to notate it as being P prime if you did in fact flip your transparency and reflect it. Okay, so down here with example 3, you're going to notice these parallel lines like we talked about in the beginning. If you trace a pair of parallel lines, finish tracing that, and you draw your line of reflection, you pick up your transparency, you flip it, you make sure that that blue line matches exactly like it did for your line of transparency, you're going to notice that your reflected lines, if you retrace them, are going to be parallel. If they start out as parallel, they're going to end as parallel because we're not changing the size, we're not changing the shape, we're not changing the distance between them, we are just changing where they are on a figure, on a plane. Okay, so everything else stays the same. So what I'd like for you to do is take this knowledge, understand how to reflect, have your line of reflection, pick up your transparency, flip it over, make sure the line matches up, and redraw them. Now, I'm no artist, so if I redraw a figure, even though I know it's supposed to be the same size and shape, sometimes it doesn't turn out like that, and I understand it, but I do want you to get as exact as you can with the problems on pages 13 and 16, please. Now, once you've tried those, I want you to look at these examples as well. We did reflections so far on just plain planes. There weren't any grids or anything, but you can also do a reflection on a coordinate plane. There is no need for a transparency if you are on a coordinate plane because you can count the distance from the line of reflection, wherever that is. Remember I said it can be diagonal, horizontal, vertical, it doesn't matter. Okay? The key is it has to be exactly the same distance from the line of reflection for the original as the new. So if this is ABC, right? I count. A is 1, 2 away from the line of reflection, so I go that exact same distance, 1, 2, and I know that this would be A prime. This one was B. If I go 1, 2, 3, 4, 5, then I count 1, 2, 3, 4, 5, and this one would be B prime. Now, that's the biggest mistake that we see in reflections. People say, well, this is C. Sorry, guys. If this is C right here, then C would have to be this one. That's if it's a translation. This is a reflection. If C is only 1, 2 away from the line of reflection, then you count 1, 2, and this one would be your C prime. Okay? Here, if I know that the line of reflection has to be the exact halfway between this point and this point, if it's 2, half of that is 1 away, so this would be my line of reflection. My line of reflection would be y equals that -2 right there. So I would draw it, and I would go 1, 1, and I would reflect each of those points. If this one was 1, 2, 3, 4 to this line 5 to this line right here, then I go 1, 2, 3, 4, 5, and there's that same point. So now if you're at this one, this third one, this is one for us to try. So if I try this one, and I say, okay, if this is my line of reflection that I have to reflect, for D, I say it is 1, 2 away. Then I count 1, 2. This right here would be where my D prime is. A is 1, 2, 3, 4. So I count 1, 2, 3, 4. Right here would be my A prime. Notice I have to do that prime notation. C is 1, 2. So I count 1, 2. I don't move it up or down. I go exactly where it is. That's my C prime. And B is 1, 2, 3, 4. So I count 1, 2, 3, 4. Right here is that B prime. Now, when I connect these, because it started out as a figure, it needs to end as a figure. I connect my points. You should notice the size and the shape are exactly the same. This is 2 segments because this was 2 segments long, 2 units long. This is 4 units because it's 4 units on each one. Size and shape do not change. It's just where they're at on the plane. We didn't need a transparency because we can count the number of units when you're on a coordinate plane. Okay, so let's summarize what we've learned today. We know that a reflection is another type of basic rigid motion. A basic rigid motion preserves, which means it keeps it the same, preserves length So the side length and the measure, so the angle measure, that means it's the same size and same shape. You have to reflect across a line of reflection. That's going to be super important with everything that we have so far. And a reflection maps each point back to itself. So I hope this was beneficial. Make sure that you have completed pages 13 and 16. Have any questions or comments ready to go for us tomorrow in class. Have a great night.